Hey dosers, welcome back to yet another video, and today we are going to be covering even and odd functions. And you must be wondering, I thought even and odd only applies to numbers. Well, I guess not according to the Maths AHL syllabus. Let's get right into it. So even and odd functions. So this page right here is for your own convenience. I will be going through it in this video in major detail so that you understand it. So I just want you to pause the video real quick and go through it very quickly and very briefly. Okay, hopefully you've paused the video and gone through it, so let's get right into it using the examples given. So even and odd functions, they don't really have a wordy definition, and the only thing that you need to remember over here is that f of x, f of negative x, sorry about that, f of negative x is equal to f of x. That is an even function. That's the definition. For an odd function, f of negative x is equal to negative f of x. That is what you need to know. But still, for your convenience, once again, I'm going to read out the definition that's given over here. This is the definition. So a function f of x is even if f of negative x is equal to f of x. This is the most important part over here. For all x in the domain of f, the graph of an even function is symmetrical about the y-axis. We don't really care about that. The main point over here is this part over here. This, and in this definition down here, this is the main part right here. And I'm going to be explaining that. So let's take the example question that they've given over here. So f of x is equal to x squared. So they've asked us prove whether this function over here is an even function, right? So we pull up our definition of an even function, which is f of negative x should equal to f of x. So it would be easier to consider values in this case. In most questions, it's easier to consider values and seeing, but in most questions, at least the more complicated ones that they'll give you in the IB syllabus, you cannot input every single value that is possible from negative infinity to infinity, so you have to consider x when you're plugging it in. So let's consider f of negative x. So when you plug in f of negative x over here, you're plugging in negative x to the power of 2. That is what's happening over here. And you look at this equation over here and you think, huh, so if I plug in f of negative x, whatever x value I plug in, whatever negative x value I plug in, will that give me the same answer? Will that be equal to x squared? Now, hopefully you should realize that yes, this will give you the same answer, that these both are indeed equal. So that proves our definition of an even function. It proves to us that f of negative x is equal to f of x, since we plug it in and it works. Now let's move on to odd functions. So our odd function is f of x is equal to x cubed. So now we do the same thing, we just go back and we check our definition of an odd function and an even function. So that's our even function. Now let's try for our odd function. So f of negative x, f of bracket negative x is equal to, outside the f of x function, like that. So that's our definition of an odd function. Yes? So now let's try proving it using the variable negative x, not using numbers. And remember, don't try to use numbers when they give you a question, as it will be really difficult. You might be able to input from 0 to 10 values, but when they're asking you a question and they're giving you a graph or they're giving you a function, they're going to be considering values from negative infinity to infinity. So do not try plugging in actual values and just try using the variable as much as you can. So f of negative x over here is negative x to the power of 3. So now you got to look at this and think, is negative x to the power of 3 the same as x to the power of 3? Well, let's see. If you do negative x to the power of 3, that means it's basically negative x squared times by negative x, which will give you a negative value. And if you do this, x to the power of 3, just x, you get a positive value. So immediately you can tell that these both are not equal in any way. And that proves to us that we should get our negative value. So the only difference over here is that because they're both not equal, the only difference is that the value that you get from plugging in negative f of negative x, you will get negative y, right? But if you plug in only x to the power of 3, if you plug in only x, you should get a value of y. That's the difference. So technically, it proves the definition of f of negative x is equal to negative f of x. So yeah, now let's move on to a question. Now I want you to pause the video and go through this question. So immediately here, when you look at this question, the first one, let's tackle A first, yes? So when you tackle A, you gotta figure out that, okay, what is the test that we do? So we have to plug in f of negative x and we have to see what we get at the end. Is it f of negative x is equal to f of x, or is it f of negative f of x, right? So that's what you have to do right now. So you have to plug in negative x into your equation. So let's plug it in. So we have f of x as a, f of x is equal to 1 over x. So f of negative x will obviously be negative 1 over x. This is an odd function. Odd. Clear? Now let's move on to b. G of x is equal to x to the power 4 plus x squared. So g of negative x should be equal to negative x to the power 4 plus x, negative x to the power of 2. So this to the power of 4, since it's an even number, and this to the power of 2, since both of these are even numbers, they should give you the same answer as plugging of both of these when you plug in x and negative x. So this is an even function. Yes? Now let's move on to c. So over here we have x squared minus 2x plus 3. So this is a little bit tricky over here. So x squared minus 2x plus 3. So now we do the same thing. We still plug in negative x into our equation. So it goes negative x to the power of 2 minus 2 to the power of negative times minus x plus 3. Now in this case over here, you know this part is going to be positive, but you don't know about this part, do you? And you don't know what the value is that you're going to get, and it's a really confusing situation that you have here. And from this part over here, you can't really figure out, because this is going to be equal to x squared plus 2x plus 3. And our actual normal equation was x squared minus 2x plus 3. So both of these are not equal, but at the same time, you can't say this is odd or even. You can't say any of them. So the answer is neither for C, because you just can't tell whether this is even or odd from this plugging in from our proof. And yeah, those are the 3 questions, and hopefully you got all those right. Now I have posted a challenge question for you guys, all of you guys to attempt in your own free time, and this is a little bit of a tricky one, but I just want you to remember that whenever you're using this, I want you to consider the 2 odd functions to be g of x and f of x, right? And a little bit of a hint is that h of x, sorry, why am I doing equals to sign? Hint is h of x is equal to g of x plus f of x. That's a little hint for you, right? Because it says the sum of 2 odd functions is also an odd function. You have to prove this is an odd function, considering that both of these are odd functions. So this is a little bit of a hint, and I do not want you guys to use any sort of numbers, only pure proof based on the variables and the functions that I have listed and given you hints for right now. So please do try that. The mark scheme is given on the next page, and if you do not understand that, let me know in the comments below and I will explain it in the next video. Thank you very much for watching. Have a good day, and remember, the Canva slides are in the description below, and the Calendly link for one-on-one sessions with me are also below in the description below, and is completely free to use. So take care, have a good day.